Hello friends, welcome to Learner's Planet. Friends, this is our third session for this algebraic and logarithmic inequalities. Though logarithm we have not yet not started, but I hope in algebraic inequalities you might have gained at least some confidence in the last two sessions. So in this session we will be doing problems based on algebraic inequalities where we have to find out the integral solutions, the maximum value, the minimum value, and so many things. Okay, so this is a practice session, so I'll be taking enough number of problems, so even if you don't have any other source of problems, still there is no problem, right? But the one thing that I would suggest is whatever the problems I am taking over here, so since we have already discussed the basic concepts, I would suggest you just pause the video and try to solve the problems on your own, then watch the solution. Okay, so this way you will be able to practice with me. And friends, each and every question which I am going to discuss in this session is specifically chosen, worth doing, well picked up. Okay, and few questions are from previous year CAT papers and from mock test papers of various institutes. Some of the students have sent doubts also, so that also whatever the related questions are there, I'll be taking in this session. Okay, so let's begin the class. Now friends, since we have discussed maxima and minima, this calculus theory also, and we have discussed VV curve method also, so if even if the questions are if the both the concepts are there, then also we should be able to solve, right? So gradually let's take one by one problems. So in the series, the first one is x cube minus 5x square plus 8x minus 4 is greater than 0. That means we have to find out the values of x for which this expression is greater than 0. Okay, greater than 0, not greater than equal to, exclusively greater than 0. Now since this is a cubic equation, let's try to solve it. First of all, let's try to factorize it precisely. Okay, so here I can say 1 plus 8 is 9 and minus 5 and minus 4, that is minus 9. So 9 minus 9 is 0. That means x minus 1 is a factor of this equation. Okay, so I can divide this by x minus 1. So here it is x square, 1 minus 5 is minus 4, minus 4 plus 8 is plus 4, and 4 minus 4 is 0. So this is x square minus 4x plus 4. So this is x minus 2 whole square and x minus 1. So this expression has been converted to this. Okay, x minus 1 into x minus 2 whole square. Now since we want it to be greater than 0. Now this expression x minus 2 is having an even power, so it will not make any impact on this expression to be positive or negative, even if x takes any value, any real value. Okay, so we just have to skip that, just have to solve this. So x is greater than 1. So whenever x is greater than 1, this expression x cube minus 5x square plus 8x minus 4 will be greater than 0. So the solution to in this inequality is 1 to infinity, right? We will use this round bracket only because the inequality, in this inequality we have been asked greater than 0, not greater than equal to. If we are asked greater than equal to, then this will be 1 to infinity. Okay, now the next question which can be asked is, what is the smallest integral value of x for which this expression is greater than 0? What is the smallest integral value of x for which this expression is greater than 0, right? So the smallest integral value will be 2. Okay, because 1 is not included. If it is greater than equal to 0, then the answer would be 1. Okay, so the question will be, what is the smallest integral value of x for which this expression is greater than equal to 0? Okay, so question can be asked in any manner. If you are able to solve this inequality, you can answer all the questions very easily, right? Now friends, let's see this question. Find all the values where n belongs to n for which the following equation has no solution. Okay, so this is just an equation, so let's cross multiply this. So x square minus 8x is equal to n square minus 10n. So x square minus 8x minus n square, or I can say plus n square, just a moment, minus n square minus 10n is equal to 0. Now this is a quadratic equation, and as we have discussed in the previous class, that when a quadratic equation doesn't have solution, that means b square minus 4ac is less than 0. Okay, the three interpretation we did in the last session. This curve will not intersect x-axis at all. This curve will not even touch x-axis at all. That means no solution. Okay, or in other words, the discriminant should be less than 0, right? Minus b plus minus b square minus 4ac upon 2a. So if the quantity, the expression under the square root, if it is less than 0, that means we will not have the real solution for this equation, right? So precisely we have to do b square minus 4ac to be less than 0. So what is b square? Here it is 64. Minus 4a is what? 1. C is what? Minus. So I just make it plus. N square minus 10n should be less than 0. Not less than equal to, it should be strictly less than 0. So I can take 4 as common. So 16 plus n square minus 10n should be less than 0. Okay, so I can factorize it. N minus 2, n minus 8 should be less than 0. Okay, so since we are looking for the integral values only, so between 2 to 8 all the values are favorable solution, right? So how many integral values we are having? We just have to take less than 0, so we cannot include 2 and 8. So it is 3, 4, 5, 6 and 7. Friends, we have 5 values for which n minus 2, n minus 8 is less than 0. But what is the question? Question is find all the values for which the following equation has no solution. So apart from these 5, we have one more value of x for which one more value of n for which we will have no solution for this equation. That is nothing but 10. Okay, because n minus 10 is there in the denominator. Okay, so n cannot be 10. Okay, so if n is 10, we will not get the real solution of this equation. So apart from these 5, one extra value we have. Okay, so this question is really important, a very important concept we have discussed over here. Apart from less than 0, one more value of n that will make this that will give this equation no solution, right? When n is equal to 10. Okay, so in all we are having 6 integral values for which n can take, for which this equation will not have real solution or which not have solution. Okay, so it's very important question. Okay, so we have discussed the concept of two concepts, as I have told you, are merged over here. You should be knowing b square minus 4ac is less than 0 when you are looking for no solution of the quadratic equation. Then you should be able to solve the this inequation using wavy curve method. So as I told you in the previous session, the question may be asked by merging the concepts. Two concepts can be asked in a single question. Okay, but over here two concepts, and apart from that one this important point, when n is equal to 10, this point. Okay, so I hope this thing is clear. A very good conceptual question. So we are discussing in how many ways a single question can be asked. So one more in the series. M is the smallest positive integer such that n is greater than m. Also it is known that n cube minus 7n square plus 11n minus 5 is positive, then the possible value of m is. Okay, so if this expression is positive, that means this equation doesn't have any real solution. The first thing that we are picking up is equation does not have a real solution. Okay, so if this equation doesn't have real solution, that means this equation it is greater than 0, that means it doesn't have any solution. Okay, so the first thing is, since it's a cubic equation and 1 plus 11 is 12 and 7 and 5 is 12, so x minus 1, precisely n minus 1 is a factor. Okay, so I just take positive 1. So it is n square 1 minus 7 minus 6n minus 6 plus 11 is plus 5. 5 minus 5 is 0, right? So n square minus 6n plus 5 can be further factorized as n minus 1, n minus 5, and already n minus 1 was a factor. So precisely now we are having n minus 1 whole square and n minus 1 5, and this has to be positive. Okay, since we have been asked that it should be positive, so it should be strictly positive, even you cannot include 0, right? So it should be greater than 0, you cannot take greater than equal to 0. Now since n minus 1, that is in their whole square, so it will not make any impact. So n minus 5 has to be greater than 0, that means n has to be greater than 5. Okay, so the least value of n will be 6, least value, because n has to be an integer that is greater than 5. So the smallest integer that is greater than 5 is 6. Okay, so the possible value of m, if we look at options, so 4 and 5, two are answers, but largest possible value of m, if we are asked, then the largest possible value is 5. Okay, so n is, since n is greater than 5, so m can, maximum value m can take is 5 only, right? Minimum value of n is 6. So this is how the questions are asked. So once again, a simple concept, wavy curve method we have used to solve this inequation, right? For how many integral values of x, fx is less than equal to 0, right? So we are looking for x square minus 3x plus 5 to be less than equal to 0, right? So if you try to factorize it, it will not be, you will not be able to factorize it immediately on ekdam quickly. So let's calculate the discriminant. Okay, so discriminant is b square, that is 9 minus 4 into 5, 20. So it's negative. Okay, that means the roots of this equation are not real. Not real roots. Okay, so if the roots are not real, that means what? B square minus 4ac is less than 0, so roots are not real. That means this expression will always be positive. X square minus 3x plus 5 will always be greater than 0. It will not be even equal to 0, right? So for how many integral values of x, fx is less than equal to 0? No integral value, 0 is the answer. Okay, no value of x can make this equation less than equal to 0. Okay, so I hope this thing is clear. So in other words, if you are asked to find out the minimum value, see, the minimum value will also be greater than 0 of this in this case. Okay, because this expression is always positive. Whatever the value of x you wish to take, you can take. This expression will be positive. And if you wish to calculate the minimum value, let's calculate that. So here fx is x square minus 3x plus 5. So f dash x will be 2x minus 3. So that we have to make as 0. So x is equal to 3 by 2. We will get the minimum value of this expression. Okay, so here it is 9 by 4 minus 3 into 3 by 2. So that is 9 by 2 plus 5. Just solve it and you will get the minimum value of this expression. Okay, and that will be definitely positive, right? So I hope this thing is clear. Now I have clubbed all the concepts over here, right? Here 6 types of questions I have taken, more can be framed. So for I have just 5 problems over here. For each and every problem you can be asked find integral values of x, for which maybe I take the first question and I'll read the complete question. Just listen to me carefully. Find integral value of x for which 2 minus x square is greater than equal to 0. या फिर find sum of integral values of x for which this expression is greater than equal to 0, or find the smallest integer x for which this expression is greater than equal to 0, largest, smallest positive, largest negative, whatever, right? So for a single expression like this, The 6 questions I have already written over there. Sometimes the mn based question, the largest, maybe m is the largest integer which can make this expression to be positive. So what is the minimum value of n? What is the maximum value? Various questions can be framed. You just have to solve this inequality. Once you solve this inequality, you will be able to answer each and every question very easily. Okay, now let's take the first one. 2 minus x square is greater than equal to 0. So if I just multiply both the signs by negative, the sign of inequality will be changed. So here it is x square plus x minus 2 should be less than equal to 0. That means x minus 1, x plus 2 is less than equal to 0. Okay, so here it is minus 2 and here it is 1. Right? So x should be between minus 2 to 1, both inclusive. Now since you have solved this inequality, so find integral values of x. So क्या क्या होगा? Minus 2, minus 1, 0 and 1. This is your answer. Find sum of integral values of x. So it is minus 2. Find the smallest integer x for which. So smallest integer is what? That's minus 2. Find the largest integer x for which. So that is 1, because we are limited between minus 2 to 1. So these are just our range for integers. Okay. Find the smallest positive integers. The smallest positive integer is 1. Largest negative integer is minus 2. Okay. So I'm sorry, that is minus 1. So you can answer each and every question once you have solved this. Okay. So I hope this thing is clear to you. Similarly, let's take the next question. Now here we are having the modulus sign. So as in the previous session we discussed modulus. So if modulus of x is equal to 5, that means x should be, if it is greater than 5, then x should be greater than 5 or x should be less than minus 5. In both the cases, modulus will be greater than 5, right? So whenever we are solving inequalities based on modulus, then we have to solve two inequalities. So here x square minus 4x is less than 5. Modulus of x square minus 4x is less than 5. So that means x square minus 4x should be less than 5 and it should be greater than minus 5, right? So from minus 5 to 5, it should be over here, right? We just have to take the less than equal to sign. We cannot take equal to, just less than sign, not equal to sign. Okay. So if any expression is, this expression is less than, modulus of this expression is less than 5, that means this expression should lie between 5, minus 5 to 5. Okay. Now we have to solve two inequalities. So x square minus 4x plus 5, it should be greater than 0, and x square minus 4x minus 5, it should be less than 0. So we have to solve two inequalities. Okay. So here in this case, let's see, b square is 16 minus 4 into 5, 20. So it's negative, right? So that means b square minus 4ac is less than 0. That means roots of this equation are not real. That means this expression will always be positive. Always positive. So no need to solve this. Okay. For any values of x, x square minus 4x plus 5 will be greater than 0. Okay. So we will not get any solution from here. Okay. Now let's check this. So let's factorize this. This is x minus 5, x plus 1, and that should be less than 0. So here minus 1 to 5. So now if we are looking at the integral values, so they should be between minus 1 to 5. So it is 0, 1, 2, 3 and 4. Right? Neither minus 1 nor 5 can be included. So we have 5 integral values of x for which x square minus 4, modulus of x square minus 4x will be less than 5. Okay, we have 5 integral values, or x can take 5 integral values for which modulus of x square minus 4x will be less than 5. Okay. Now other question you can answer very well, very easily. A sum of integral values, so that can be all these numbers can be added. Then smallest positives, largest positive, all the questions can be answered very easily. Largest positive integer is 4, smallest integer is 0, smallest positive integer is 1, sum of the integers is 4 and 3 7, 8 9 10. So all the question can be answered very easily, right? So I hope this thing is clear. So we have done second one. Now a modulus of x square minus 2x minus 3 is less than 3x minus 3. That means x square minus 2x minus 3 should be less than 3x minus 3, and it should be x square minus 2x minus 3 should be greater than minus of 3x minus 3, right? Uh, Same as in the previous case, modulus of this number, maybe I take it is if it is greater than 3, so p should, I'm sorry, less than 3, so p should be greater than minus 3 and p should be less than 3. That means it should lie somewhere in between. Okay, so similarly, since x square minus 2x minus 3 modulus of that is less than 3x minus 3, so this expression should lie between minus of 3x minus 3 and positive of 3x minus 3. Okay, so we have written both of them. So now let's solve both of them. So here x square minus 2x and minus 3x, that is minus 5x, it should be less than 0, and here, or you can just solve it very easily. So here it is 0, here it is 5, so between 0 to 5. So here it is 1, 2, 3 and 4 integral values if you are looking at. Okay, and here it is x square minus 2x minus 3 is greater than minus 3x plus 6. Okay, so x square minus 2x minus 3x, that is plus x minus 9, that should be greater than 0. So I'm sorry, here it is 3 only. So 3 and 3 6. So the factors will be x plus 3, x minus 2 should be greater than 0. So here it is minus 3, here it is 2. So it's less than minus 3 and more than 2, right? Solution set of this is minus infinity to minus 3 union 2 to infinity. So since we have solved both the inequations, now we have to club them to get the final answer, because we have to club to get the final answer, as values of x should satisfy both the inequalities. Okay, so how do we do that? How to club the answer? Just a moment. So this is a number line that I have drawn. Okay, then just mark the points 0 to 5, 0 to 5, then this is minus infinity to minus 3 and union 2 to infinity, so they are 2 and this is infinity. So this is 0 to 5, so I just mark that 0 to 5. Okay, then let's mark this minus infinity to minus 3 and then 2 to infinity. So 2 to infinity. So what is the common range that we can see over here is 2 to 5, right? So x can take any value from 2 to 5. 2 to 5, sorry, both inclusive. So if you are asked how many integral values x can take, so x can take 2, 3, 4, 5, 4 values, right? Smallest integer 2, largest integer 5. So all the questions can be answered very easily, right? So what is the pickup of this problem? So you are solving the modulus problem. You need to solve two inequalities, and to get the final answer you need to club the solutions, right? So if you are not clubbing the solution, you will not get the correct answer, because suppose you maybe I just give you one simple example. Now, if you do not club, so what can happen? See here the solution for this, the second one, when x square minus 2x minus 3 was greater than minus 3x minus 3. So from this range, you can take a value, suppose maybe between 2 to infinity, the value which is not there in this in this equation precisely. So that is suppose 6. I take 6, it is not there in this, but it is applicable for this, right? Because the favorable solution is minus infinity to minus 3 and 2 to infinity. So 6 is a number that is part of this, but it is not part of this. But if you put 6 over here in this equation, what you will get? X square minus 2x minus 3, so 36 minus 12 minus 3, so modulus of 36 minus 12 minus 3. So if you solve it, 36 minus 12, 24 minus 3 is 21, and on the right hand side you get 6 3s are 18, 18 minus 3, 15. So you will get 21 is less than 15, which is wrong. Okay, so once again, solve the inequality individually, then club the solution. And how do you club the solution? Just mark the points over here on the number line and find the range that is common to both the inequalities, and that is very, very important. Okay, so the common answer of the which you get is 2 to 5, right? So from 2 to 5, so 2, 3, 4, 5, you have 4 answers. Okay, I'm sorry friends, here 5 cannot be included since we are just looking for less than so 5 cannot be included, because at 5 the expression, the value of this expression will be 0, so even 5 is not there. Okay, so 2, 3, 4, these are the 3 integral values only. Okay, or if you are looking at the complete range, then it is 2 to 5. Okay, so immediately below 5 the number is included. So this is a real number range, and this is integral values. Okay, I hope this thing is clear. Let's take one more problem. So if at all you have any confusion, that will be cleared. Now let's take this. First of all, we take this. Let's take fifth one. Then I will explain this one. So modulus of x minus 6 is x square greater than x square minus 5x plus 9. That means x square minus 5x plus 9 is greater than minus of x minus 6, right? And x square minus 5x plus 9 is less than x minus 6, right? So this should lie in between. Okay, so let's solve them individually. X square minus 5x and plus x, so that is minus 4x, plus 9 and minus 6, so that is plus 3, and that should be greater than 0. So here it is x minus 3, x minus 1 greater than 0, so 1 and 3. So the solution set to this is 1, 2, 3. Okay, so this is 1. Then we are looking at x square minus 5x plus 9 is less than x minus 6. So it is x square minus 4x, I'm sorry, 5x and minus x minus 6x plus 15. Okay, it should be less than 0. So if we take b square minus 4ac, so that is 36 minus 60, right? So that is negative. Okay, that means discriminant is negative, so no real roots. That means this expression will always be positive. X square minus 6x plus 15 will always be greater than 0. Okay, so just eliminate this. So you just have to take the values from 1 to 3. That's it. Okay, so integral value will be just a single, that is number 2. Right, because 1 and 3 both of them are not included. At 1 and 3 this expression will be 0, because 1 and 3 both of them are roots of this equation. Okay, so there's a single integral value, So how many integral solution it can take? That is just single, that is 2. Okay, so it is that easy. Once you are clear how to solve inequality, you can do any questions. Okay. Now let's see this one. X square minus modulus of x minus 2 is greater than equal to 0. So if we factorize this, we'll get modulus of x plus 1 modulus of x minus 2 should be greater than equal to 0, right? So here in this case we have instead of x we have modulus of x, so treatment will be bit different, right? So if product of these two expression is greater than equal to 0, that means either both of them should be greater than equal to 0 or both of them should be less than equal to 0. So first case I consider both of them are greater than equal to 0. That means modulus of x plus 1 is greater than equal to 0. That means modulus of x is greater than minus 1. Okay, so that greater than equal to minus 1, that means, and modulus of x definitely is a positive quantity, so it has to be greater than minus 1, and modulus of x minus 2 is greater than equal to 0, that means it should be greater than equal to 2. So if we club both of them, modulus of x should be greater than, in this case modulus of x should be greater than minus 1, and in this case modulus x has to be greater than equal to 2. That means if we club them, the final answer is this: modulus of x should be greater than equal to 2. Okay, so modulus of x will be greater than equal to 2 in this range. Okay, below minus 2 and above 2. So x should be minus infinity to minus 2 included, union 2 to infinity, right? So now this is the first case. Now when both of them are negative, that means modulus of x plus 1 should be less than equal to 0. That means modulus of x should be less than equal to minus 1, which is not possible. So we will not get any solution when both of them are less than 0. So this is our final solution. Okay, now the smallest integer, largest integer, the smallest positive integer is 2, for which this x square minus modulus of x minus 2 is greater than equal to 0. The smallest integer is 2. The largest negative integer is minus 2, and other questions can be answered which are applicable, right? You cannot find out the sum of all integral values over here. You can find out the smallest integer, you can find out the largest, smallest positive, largest positive. Okay, but the integral values, all the integral values and sum of all the integral values cannot be found. If there is certain range given that x belongs to minus 10 to 10, then definitely you can find. Okay, so this is how we can solve this modulus based inequalities. Okay, and as I've already discussed, how many questions for a particular question, a particular expression can be asked, right? So if you are clear with the concepts, you can answer all the questions very easily, very quickly. Now let's try this one. Find largest integral x or integral x which satisfy the inequality x4 minus 3x cube minus x plus 3 is less than 0. So here 1 minus 3 minus 1 and 3. Okay, so x minus 1 is a factor, or what I can do is from these two I can take x cube as common, then x minus 3 minus 1 common, x minus 3. So the factors will be x minus 3 and x cube minus 1. So x cube minus 1 will be x minus 1 x square plus x plus 1, right? Now we want it to be less than 0. Now these three expression, out of these three, this expression we cannot consider because this is always positive. We can drop it, right? This will always be positive because x square plus x plus 1, it is b square minus 4ac. The discriminant will be negative, so this is always positive, right? So this expression is always greater than 0. Now we just have to solve x minus 3, x minus 1 is less than 0. So that is this. So x should be between 1 to 3. Okay, none of them is included. Now but we have been asked integral value of x, so we just have one integral value of x, that is between 1 and 3, so that is 2. So just a single solution for which this expression is less than 0. Okay, x is 2 when this expression is less than 0. Apart from 2, there is no other value which can be assigned to x, so this equation will be less than 0. Okay, so that's very important, very interesting, very simple question. I hope this thing is clear. Once again, I take up x cube as common and we got this factorization. Then x cube minus 1 can be written as like this. After that, this expression we can skip because x square plus x plus 1 is always positive. So we can skip that. So x minus 3 into x minus 1, that should be less than 0. So x should be between 1 to 3. Right? Since we are looking for the integral values of x between 1 and 3, so there is a just single value, that is 2. That's it. Okay. So largest, smallest, whatever the value, that is single value 2 only. I hope that's clear to you. Now find largest integral x which satisfy this inequality. So in this equality we have 1, 2, 3, 4, 5 expression, but we can drop these two because they are perfect squares, so they will not make any impact. So x plus 1, x minus 5 and x minus 2. I just put up the zeros over here, so that's minus 1, 2 and 5. Okay, so we are looking for this expression to be less than 0. Test it between 2 to 5 and minus infinity to minus 1. Now what will be the solution to this problem? We are looking for the largest integral x which satisfy this inequality. So we get this range minus infinity to minus 1 union 2 to 5. So the largest integer which will satisfy this range is 3 and 4. Both of them, right? But just look at the question. Look at the question. At x is equal to 3 and 4, this expression will be 0, and we are looking for less than 0. So you have to still eliminate 3 and 4. Okay, so now you switch over to below minus 1. So below minus 1, the largest integer is minus 2. So the answer to this problem is not 3 and 4. The answer to this problem is minus 2. Okay, so that's very important. Pick up over here. Just be very careful while you mark up the answer, right? You may end up making mistake. Once again, initially we are dropping 3 and 4 because that they will not make any impact whether their x is positive or negative. It is more than 3 or more than 4, both these expression will be positive. So we left them. For x plus 1, x minus 5 and x minus 2, we are marking the zeros over here. So the favorable range for real numbers is minus infinity to minus 1 union 2 to 5. But we are looking for the largest integral value of x, right? So between 2 and 5, we have the integral values as 3 and 4. But at 3 and 4, this expression is not less than 0, but it is equal to 0. So even if you are looking for the integral values of x, you need to skip 3 and 4, both of them. Right? After that, the largest integer will be less than minus 1, and that should be between this range. It should lie between minus infinity to minus 1. So the largest one is minus 2. Okay, so the largest integral which satisfy this inequality is minus 2. Clear? See, each and every question whatever I am solving in this session is, once again I'm telling you, it's well picked up. Each and every question is just taking a different concept, a twist. Okay, so how many times you just have to be very careful while you are marking the answers, right? Maybe this in CAT, these sort of questions may be theta questions, right? So you may think like there are 3 options or 3 answers, 3, 4 and whatever, right? 2, 3, 4, 5 out of maybe 3 answers, maybe 4 answers. But you need to take care the given conditions also, that x cannot be 3, x cannot be 4. Okay, so be careful while you are solving the questions. Now let's see this one. 4x plus 19 by x plus 5 is less than 4x minus 17 by x minus 3. So I put negative and it's less than 0. So just quickly multiply this. 4x square minus 12x plus 19x minus 57 minus 4x square minus 20x plus 17x plus 85 by x plus 5 x minus 3 and it should be less than 0. So here it is 7x, here it is minus 3x, and 85, 57, that is 28. So 7x minus 3x, that is 4x minus 28. So I can say it is x minus 7 upon x plus 5. X minus 3 should be less than 0. Now we are done. It's minus 5, here 3, and here it is 7. Okay. I'm sorry, it is plus 7 over here. So here small calculation error I have done. Here 7x plus 28, so it will be x plus 7. Okay. So here it is minus 5, minus 7 and 3. Okay. Now we want the largest integral value of x. So that will the favorable solutions are from minus 5 to minus 3 and minus 7 to minus infinity to minus 7. Since we are looking for the largest value of x, so that should be between minus 5 to 3, right? Okay, so we are looking at less than 0, not equal to 0. So at 3 it will be equal to 0, or that is also not defined because x minus 3 is there in the denominator, right? So immediately below 3 we have the number that is 2. Okay, so the largest integral x that will satisfy this inequality is 2. X is equal to 2, right? So that's pretty simple. I hope you are clear with this. Now based on the same concept, let's take this problem from CAT 2017 paper. It's a theta problem. So you have to solve the problem completely. No, you cannot take the help of options, dear friends. Okay. So the concept is same. If you have done all the question religiously that we have discussed in this session, you can do this problem very easily. So here, what we have to do, first of all, need to factorize it. So n square minus 15n plus 50 minus 3n plus 6 should be less than equal to 0. So this is n square minus 18n plus 56, that should be less than equal to 0. So that is n minus 14, n minus 4 should be less than equal to 0. So here it is 4 to 14. Okay, so we are looking for less than equal to 0. So from 4 to 14, how many integers are there? 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, and 14. Okay, so how many integers are there? 11. Okay, so if you know this concept, within 30 seconds you can answer this problem, right? Very easily, very quickly, very confidently, because this will never be wrong if you are clear, right? So in all there are 11 integers, or n can take 11 values for which this expression is less than equal to 0. Since here we have less than equal to 0, so I have included 4 and 14, both of them. Okay. So the next question is, once again the problem is from CAT 2017 paper, theta problem. So you need to solve it completely. You cannot take the help of options. X square plus 11x plus n and x, the largest positive integer n for which this equation has two distinct real roots. Okay friends, so x square plus 11x plus n is equal to x, so I can say minus x is equal to 0. So x square plus 10x plus n is equal to 0. Now this is a quadratic equation and we want to have two distinct real roots. That means once again we have three situations as we discussed in the previous session, and I had already told you the question, in the questions the concepts will be clubbed. Okay, so you should be knowing that b square minus 4ac should be greater than 0 to have two distinct real roots. Okay, this is b square minus 4ac greater than 0. This is b square minus 4ac equal to 0, and this is b square minus 4ac less than 0. Okay, no solution. Both the solutions will be same, both the solutions will be different. Okay, that means b square minus 4ac should be greater than 0. So what is b square? That is 100 minus 4ac, so that's 4n square. That should be greater than 0. Only greater than, not equal to. In case of equal to, you will have both the solutions to be same, but we are looking both the solutions to be different. Okay, So 100 minus 4n square is greater than 0. So I can say n square minus 25 is less than 0. So n minus 5, n plus 5 is less than 0. So minus 5 to 5, right? So n can take any values from minus 5 to 5. Now since we are looking for integral values of x, so they are from minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. That's it. At minus 5 and 5, this will be 0. But we are looking for two distinct roots. So we need to skip minus 5 and 5, both of them. Right? So 1, 2, 3, 4, 5, 6, 7, 8, total 9 values will be there. And since this was a theta problem, you need to calculate it accurately. Okay? Then only you will get the correct answer. Full marks. Okay? So I hope this thing is clear to you. So many problems and concepts we have discussed in this session. Now I'm sure you must have gained at least some confidence in solving the problems on inequality. More tedious problems, more challenging problems I'll be taking in the next session. Once we finish up this series, I'm 100% sure that you can take any challenging problem based on inequalities. Okay, so have a good day. Bye bye.